Use the given data to complete parts A through D. Here we have a table of values: X, 230, 265, 358, 480, and 530. Our Y values are 15.9, 15.7, 15.4, 15.3, and 14.9. So these are 5 sets of ordered pairs. The value for X, 230, and the value for Y, 15.9, are an ordered pair. And we're going to find the equation of the regression line, calculate R using the formula, and we're going to see if there is evidence to support the claim of a linear correlation between the two variables. And then we're going to predict a value of Y for X equals 300. Okay, let's first calculate R. So the first thing you need to do to calculate R is make a column, or make a table with 5 columns. A column for X, a column for Y, a column for X squared, a column for Y squared, and a column for XY. Those are all parts of the formula. If you notice, in the formula we need N, we need the sum of XY, we need the sum of X, the sum of Y, we need the sum of X squared, and we need the sum of Y squared. So that's why we create these specific columns here. So the column for X, the data values in that column are simply taken from the original table, and the data values in Y are taken from the original table. You need to make sure they are in the same order. So they should be the same ordered pairs in the original table. Then you just work across. You calculate X squared by squaring the X value, calculate Y squared by squaring the Y value, calculate XY by multiplying X times Y. Then you add each column together. So this sum of X squared is just the sum of all the values in the X squared column. Okay, now you substitute the values into the formula in the correct place. So R is 5 times 28,571.7 minus 1,863 times 77.2. That's our numerator, divided by, there are 2 separate square roots in the denominator. Under the first square root, 5 times 762,589 minus 1,863 squared. Now notice here it says the sum of X in parentheses then squared. So we use the number for the sum of X, 1,863, and then we square that. And then times the square root of 5 times 1,192.56 minus 77.2 squared, and we get negative 0.9590, rounded to 4 decimal places. That is the value of R, the correlation coefficient. This by itself indicates a negative relationship and a strong negative relationship. Remember, correlation coefficients R range from -1 to +1. 0 is no linear relationship at all. +1 would indicate a perfect positive relationship. -1 would indicate a perfect negative relationship. So a negative relationship means as X increases, Y decreases. It's an inverse relationship. Or it could be as X decreases, Y increases. It could be the other way too. Okay, next. Let's test the correlation coefficient at the 0.05 level of significance. The null hypothesis is that there is no linear correlation. The alternative hypothesis is that there is a linear correlation. We use the critical values of the Pearson correlation coefficient R table, and we find that when n equals 5, at the 0.05 level of significance, where our critical value is 0.878. If the absolute value of R is greater than the critical value, reject the null hypothesis. If the absolute value of R is less than the critical value, do not reject the null hypothesis. So the absolute value of negative 0.9590 is greater than 0.878. Therefore, we reject the null hypothesis, and there is sufficient evidence to support the claim of linear correlation between x and y. So in this case, since there is sufficient evidence to support the claim, when we make predictions, we are going to use the regression equation. If there was not sufficient evidence to support the claim of linear correlation, we do not make predictions using the regression equation. We simply take the mean of the y values as the predicted y value. Okay, next we need to write the regression equation, which is y hat equals b sub 0 plus b sub 1 x times x. And here we're using the formulas to do that. So here's the formula for b sub 1. We do not need to write any or find any new columns in the table. These are going to use all the numbers that we already have from the table. So here we substitute the correct values in the formula, and we get b sub 1 equals negative 0.0028. b sub 0, again, here's the formula. We have all these numbers on our table. We substitute these values in the formula, and we get b sub 0 equals 16.4909. So y hat, the regression equation, equals 16.4909 minus 0.0028x. Now, since there is a linear correlation, use the regression equation to make predictions. What is the best predicted value of y for x equals 300? We will substitute x equals 300 for x into the regression equation. Y hat equals 16.4909 minus 0.0028 times 300 equals 15.65, and this is rounded to 2 decimal places. You would round to whatever is asked on your assessment. So the best predicted value of y equals x equals 300 is 15.65. The data here shows systolic and diastolic pressure of certain people. So x will be systolic pressure and y is diastolic pressure. Here we're going to use a calculator to find the linear coefficient r, and then we'll use the table to test the claim of linear correlation. We'll use the calculator to find the regression equation, and then what is the best predicted diastolic pressure for a person with a systolic reading of 130. So calculator. First, how did I get this? Stat. Edit. You're going to enter your x coordinates in list 1, enter your y coordinates in list 2, and then you will go stat, go over to calculate, choose this one, linreg a plus bx, specify list 1, list 2, and then calculate. And here it gives you a is negative 37.7428, b is 0.9199, and then r is 0.6206. So first we'll use r. So r 0.6206. Null hypothesis, there is no linear correlation. Alternative, there is linear correlation. In this case, n equals 8 because there's 8 ordered pairs. So the critical value at the 0.05 significance level is 0.707. In this case, we are not greater than, our calculated r is not greater than 0.707, so we fail to reject the null hypothesis, and there is not sufficient evidence to support the claim of linear correlation between systolic and diastolic pressure of certain people. So when this happens, we do not use the regression equation to make predictions. We will use simply the mean of the y values. Y hat is negative 37.7421 plus 0.9199x. This is the regression equation. So on a calculator, we are just using this information right here and y hat. So instead of y equals a plus bx, it'll be y hat. So it'll be negative 37.7428 plus 0.9199x. That's where we get that right there. And since there is not a linear correlation, we use the mean of the y values to make predictions. So we go back to our table, and we take these y values, we add them up and divide by 8 to calculate the mean. The mean is approximately, it's exactly 80.125, I believe. So the mean, though rounded to 1 decimal place, is 80.1. And the best predicted diastolic pressure for a person with a systolic reading of 130 is 80.1.